Our next section is angle measures and segment lengths. There is a special relationship between two intersecting chords, two intersecting secants, or a secant that intersects a tangent. This relationship allows you to find the lengths of unknown segments. So here is the theorem we're going to look at. And there's some ways to remember these ideas. For a given point and a circle, the product of the length of the two segments from the point to the circle is a constant along any line through the point of and circle. So if you have two chords, if you multiply A times B, it will equal C times D. A way of thinking of that is part times part equals part times part. Now, to rephrase that, this is basically saying take one chord and multiply the two parts that are created by the intersection. And that will equal the other chord's parts multiplied together. If you have two secants, the way of thinking about it is the outside part of the secant times the whole equals the outside part of the other secant times the whole. So W times W plus X will equal Y times Z plus Z. Now if you have a tangent and a secant, if you're talking about the tangent, that would be the outside squared equals the outside times the whole. Okay, T squared equals Y times Y plus Z. Now each line has two segments from the intersection, point P to the circle. The product of these segments on one line is equal to the product of the segments on the other line. You must use the entire segment length. So, let's look at example 1. So using the part times part, we'll have 4 times 7 equals 5 times our unknown, or XB. Okay, so we have 28 equals 5XB. So the length of XB is 28 over 5. Or in this case, 5.6. Okay, example 2. 3 times 4 equals X times 8 minus X. Okay, distributing, you get 12 equals 8x minus x squared. Okay, we're going to set this equal to 0. So move everything over to the other side. X squared minus 8x minus 12 equals 0. We are going to factor this. So think of factors of 12 that have a difference or have a sum of 8. And what you end up with is -2 and -6. So this factors as -2x minus 2 times x minus 6 equals 0. Solving for x, x minus 2 equals 0, therefore x equals 2, x minus 6 equals 0, so x equals 6. So either 2 or 6 are possible answers for this problem. Here we have two secants. So we're going to do outside times whole equals outside times whole. Distributing, we have 5x plus 25 equals 6 times 10. So 5x plus 25 equals 60. 5x equals 35. So x equals 7. Example 4. 11 times 11 plus 10 is 21. We'll just do that right now. Equals 12 times 12 plus x in this case, sorry. Okay, so 11 times 21 is 231. Distributing, we get 144 plus 12x. Then 12x will equal 87. Dividing both sides by 12, x equals 7.25. Okay, and finally we have a tangent and a secant. So 6 squared equals x times 5 plus x. So we get 36 equals x squared plus 5x. 0 equals x squared plus 5x plus 30 minus, sorry, just undo that. 5x squared plus 5x minus 36. Factoring, we'll have x plus 9 and x minus 4. Okay? So, when you factor this, you get x plus 9 equals 0, so x equals negative 9. And x minus 4 equals 0, so x equals 4. Now, in geometry, we'll only deal with the positive. So the one that matters will be x equals 4. Okay, and then finally, we are going to skip the last problem. And that ends this section.